Hello, good evening, everyone. Or good afternoon, everyone. Very happy to see you today. Okay, I do not know you are on. Whoever is with me here, so a very good day to you. Today, I'm going to start chapter 4, which is on chemical composition in the cell. So you can see my slides here. Okay, I'm starting with 4.1, which is actually water. All right. So if you would like to let me know who you are, you can just type a comment on the comment box. Okay. So today I'm going to share screen. I think you can see the screen here now. I'll start straight to it. All right. Okay. So 4.1 is water. So today I'm going to share with you the characteristics of water, which is a very important substance in the human body. All right. Okay. So what is the importance of water? All right. Okay. As you know, you can see this diagram. Most major part of our body is made of water. Okay. We need water in every part of our body, especially for in blood. Okay, and the lymph, which is another type of system in our body. So all of these are composed of water. Okay, what is the importance of water? Yeah, number one, okay, water makes up about 60 to 70% of the human body. Okay, which is more than half. So it's a very important substance. It maintains body temperature. So here are the functions of water. So if you have any questions to answer regarding the importance of water or the function of water, so here are the points that you can write. Okay, number one here, it helps to maintain the body temperature. It lubricates and cushions joints. Okay, because of water, it lubricates means it makes it smoother. The function of our joints actually is to provide movement. When it comes the meeting point of bones and bones is called the joint. Okay, so it has to be lubricated so that the movement will not be painful. It will be easy to move the parts of the body or the parts of the bone. Okay, next, then you have the next part, the next point, excrete waste products. Okay, of course, you have the urine, and you also have from the digestive system, we will produce what we call the feces. Okay, and that requires water because water will make it more easy or easier to excrete, to what they call to remove. Okay, we wouldn't call excrete, remove the waste product from the large intestine. But for the urine, that is the excretion system. Uh, Water is needed to produce urine. Okay. Water is the medium of biochemical reactions in the cell. Okay, all the reactions in the cell cannot occur in a dry environment. It needs to have water, which is the medium. So chemicals, enzymes, and so on, they are dissolved in water. They need the water medium, okay, the liquid medium to be able to carry out the process of these biochemical reactions. It also aids digestion, okay, prevents constipation, and also protects body tissues and organs. So you can see the list here is there is a lot. This is not the exhaustive list of the functions of water, but here are a few points that you can use to write if you are ever asked to write the function of water in your body. Okay, so next we will look at the 3 properties of water that we're going to discuss today. Okay, the first one here is polarity of water. Okay, polarity means in BM we call it kekutupan. Okay, means the charges, positive and negative charge. So if something that has positive and negative charge, we'll call it there is polarity. Then second point here is the cohesive force and the adhesive force, which occurs in water or which exists in water. And the third one here is specific heat capacity. Okay, so here you can see the molecule of water, which is actually made of 1 atom of oxygen and 2 atoms of hydrogen. Okay, so you always remember this like Mickey Mouse kind of structure on the shape of Mickey Mouse, okay, with one big round, a circle, and then 2 smaller little circles at the top, okay, that looks like the ears of the Mickey Mouse. All right, okay, let's look at this one. Now, what do you mean by polarity of water? Okay, this diagram clearly shows that You need one, in order to make a molecule of water, you need one atom of oxygen and two atoms of hydrogen. Okay, but they are arranged in a specific way. Okay, the what do you call the position, all right, of the hydrogen, the angle between the hydrogen and the other hydrogen is about 104.5 degrees. Okay, so this one will not be asked about these degrees. You do not need to remember this. Okay, let's look at this. Water is an inorganic compound. Okay, inorganic compound because water is found in the earth here. Okay, it is not made by a living cell, but exists on the earth. Okay, as an inorganic material and an inorganic substance. It is made up of two atoms of hydrogen and one atom of oxygen. All right. Now, water is a polar molecule. Okay, polar molecule means there are uneven distribution of charges. Even though we say the entire molecule of water is neutral, okay, because you have two hydrogen ions, okay, which is H plus, and then you have this O, which is 2 minus. So actually the charges are neutralized, okay, 2 minus and 2 H plus. So the charges are neutral. The entire molecule is actually neutral. But because of the position, okay, the electrons are more concentrated to the oxygen atom. The electrons are more concentrated on the near the oxygen uh, atom there, whereas so we call this, there is a partial negative charge nearer to the oxygen atom. Okay, whereas near the hydrogen side, it is more electropositive. So this one, you have a partial positive charge, okay, which you indicate with that Greek letter delta here. So delta minus and delta positive, delta negative and delta positive. So that means nearer to the oxygen, the molecule of water where there is oxygen, there will be more electronegative. Okay, so electrons are more concentrated on the side, and that leaves the other side, the hydrogen side here, less electrons. That means it is more positively charged. Okay, but as a whole, the entire molecule is neutral. All right. Okay. Now, because of that unequal distribution of the electrons, okay, one side will have more electrons, and the other side of the water molecule will have less electrons. Okay, so there will be what do you call? I see this positive, delta positive near the hydrogen, and over to the other atom, not the same atom, yeah, not the same molecule. On the other molecule, you have the delta negative. You find there exists a attractive force because positive and negative different charges attract. So if we look at another one, the hydrogen side is more positively charged. Okay, partial positive charge, whereas nearer to the oxygen is it exists the partial negative charge. So all right, so you can see the difference in that there's partial positive and partial negative charges at different parts of the molecule of water. So there exists a bond, an attractive force. That bond or that attraction is called hydrogen bonds between the molecules of water. So here it's called, the dotted line here shows an attraction. So the O will be attracted to the H. Okay, so that is a hydrogen bond. And over here, the O for the molecule of water on the right hand side will be attracted to the hydrogen part of the water molecule on the other molecule. Okay, on the other, not the same molecule, yeah. Okay, so you find there is an attraction, and that is a hydrogen bond. Right. So this hydrogen bond is important. All right. Okay. So this polarity produces the hydrogen bonds between the molecules of water. All right. Now it is because of these hydrogen bonds between the molecules of water that makes the molecule of water to become a universal solvent. Okay. What is a universal solvent? As you know, water can dissolve many things. Okay. A solvent is a liquid that can dissolve a lot of what they call the solutes, can dissolve solutes. So a solvent can dissolve solute. All right. So water can dissolve many solutes. So we call it a universal solvent. Okay. So I give you a diagram here. So if you look at salt here, I put salt in a beaker of water. All right. And then if I stir it, you notice that the salt will quickly disappear. Not really disappear, actually it dissolves. It dissolves into the solvent, which is the water. Okay, how does that work? Okay, now this is the structure of the sodium chloride. This is salt. Okay, so just imagine the purple part there, that is the sodium, all right, sodium ion, and the green one is the chloride ion. So sodium chloride. Sodium chloride is your common salt, the salt that you put into your food to get the salty taste. Okay, so if you put salt into water, and of course you stir it, and even if you don't stir it, okay, what happens here is the sodium ion will be attracted to the oxygen molecule of the oxygen part of the molecule here. So you can see, because this part here, okay, let me show you. This is, it has partial negative charges. So the part that is the oxygen that's facing the ion, the sodium ion, it will be attracted. So it actually pulls the sodium ion away from the structure. Okay, that's how the sodium ion dissolves, because it was pulled away by the oxygen, okay, in the water molecule. And reverse, on the other hand, you can see the green one, all right, that is the chloride ion, which is negatively charged. Chloride ion is negatively charged. Okay, and that will be attracted by the partial charges, which is the hydrogen part. Okay, so this hydrogen ion that is near on the molecule of water, it will be facing the chloride ion, so it pulls this away. So because of this attraction, right, the ion of sodium ion and the chloride ion gets pulled out from the lattice, from the structure, and that makes this ions dissolve in the water. All right, it pulls it out. So this universal solvent property of water, right, is important, because water, you know, is a unit. It helps biochemical reactions. Okay, so it allows solids and electrolytes to be transported into the cells for biochemical reactions. So it sends all these electrolytes, okay, potassium ion, sodium ion, all this into the cells to allow biochemical reactions to occur. Okay, so I'll show you a animation that will show this very clearly, how this attraction of these forces the ions apart. Okay, so you will see here now, sodium chloride, at first they are next to each other because of the attraction between positive and negative. But because of water also has its charges, right, which is the polarity. The oxygen will pull the positively charged sodium ion away, and the water molecule, that part is a positive, the hydrogen side pulls the chloride ion away. So you will see in that way your sodium ion and the chloride ions are dissolved in the water. Okay, so this polarity causes water to be a universal solvent. All right, okay, so this is the second, this is the first property of water which I've discussed. Okay, so it pulls that, and that it causes water to be a universal solvent. Okay, secondly, cohesive and adhesive forces. So I do not, you also learn this in physics actually, all right? Maybe not so early, not so soon in Form 4. Okay, but cohesive and adhesive forces exist in the water molecule. Okay, cohesive force. What is the meaning of cohesive force? It is attractive force between water molecules. So in between water molecule and water molecule, there is an attraction. Okay, because of the partial positive charge and the partial negative charges, there exists a attraction between molecule of water and molecule of water. So it means water likes to stick to water. Water pulls water. All right, okay. And the other, so this is diagram. You see this diagrammatic cartoon here shows that the cohesion, or we call it cohesive force, or we can also use the word cohesion, is the force that exists between, you see this one, this is the hydrogen, all right, the purple color, the gray color is hydrogen, and the red color is oxygen. So you can see they are holding hands. The holding hands is showing that they are attracted to each other. All right. So this force that exists between the water, the hydrogen, actually the hydrogen, okay, and then the oxygen side here. This force here is a cohesion force, or we call cohesive force. Okay, that is one. All right, the next one, adhesive force. There also exists another force, the attractive force between the water molecule and the surface. So you notice that water like to stick to certain surfaces. That force is called adhesion or adhesive force. So either you use the word adhesive force. If you say adhesive, you must have the force behind it. Because adhesive just full stop, it doesn't make any sense. Adhesive is an adjective. You must put the word force. Adhesive force. But if you use adhesion or cohesion, it can be on its own. Okay, so you just say cohesion or adhesion is the same meaning as cohesive force and adhesive force. So this is an oxygen here. Okay, right. So now this cohesive force and adhesive forces, both of these forces produce a capillary action. So the capillary action referring to these two forces together. So this actually helps. Okay, how does it work, or how does it help? Where can we see the application of this? This helps to explain how water can be able to be transported through the xylem in long continuous columns. So if you look at this diagram, right, this is the stem of the tree. In the stem of the xylem of the tree, you know that you have learned before that xylem cells. Xylem cell uh, transports water. So you see all these blue dots here, these are molecules of water. So water will pull water. Okay, so the dotted line in between water and water, that is cohesion. Okay, the cohesion exists because of the hydrogen bonding lah. Positive here, negative here, so there is an attraction. So cohesion is between water molecule and water molecule. Basically, it means water likes to pull water, or water sticks to water. You notice it's very difficult for you to cut water, correct or not? Am I right? It's very difficult to cut water. When you cut water, it sticks together. It goes back together. It's not easy for you to cut water, right? You can't physically separate them. It will very easy for you to join back together because of the cohesive force. And what about the adhesion? Adhesion is a force that exists between the molecule of water and the cell wall, means the xylem, or even if not cell wall, it can be beaker. When you pour water into beaker, you notice that the beaker, the side of the water that touches the beaker, it will stick to it. That is because of adhesive force. Okay, so the the attractive force between the molecule of water and the container or the xylem or any part of the surface that sticks to the water, that's near to the water, that is adhesion. Okay, and these two forces produces capillary action. Okay, so I will carry on some more. So you see capillary action, why is it important? Because it allows water to move in a continuous stream against gravity. So you notice that water is very easy to move up thin or very fine capillary tubes. And you see that it causes a meniscus. You know, meniscus, when you read you learn this in Form 1, yeah, when you read the level of water or the volume in the uh, measuring cylinder, you always look at the lower meniscus and you see it always curves. Now, why does it curve? Why does it curve? It curves because of this. Okay, do you see? Cohesion, there is this attractive force between water molecule and water molecule. And it also between water molecule and the container or the wall. In this case, is the wall of the capillary tube lah. This is adhesion. So it pulls the water up. So you can see there's going to be like a U shape here. Okay, at the side of the container, it is not going to be flat. You notice it sort of like moves upwards. So that's why you can see there's a meniscus. All right. So cohesion, so you just remember that water pulls water, that is cohesion, and water tending to stick to the side, that is because of adhesion. All right. Okay. Now in your textbook, I do not know whether the new textbook, this is the first edition of textbook when it first came out in 2021. All right, there is do you notice there's a mistake here? All right, in the textbook, if you check the textbook later, So here is the xylem vessel. The blue color dots represent molecules of water, and it's been magnified over here on the right hand side. You notice that actually there's a mistake here. All right, you check your textbook. If there is, please correct it lah. Okay, it's useful. It's important for you and also for your juniors to know later, right? That this information is wrong because they have been labeled wrongly. Okay, you notice it should be the other way around. The adhesive force is not the one between water molecule and water. And please draw from the oxygen to the hydrogen. It's not oxygen and oxygen. It's not hydrogen and hydrogen. It's between the oxygen and hydrogen. So that should be cohesive force. This is cohesive. Okay. And the one that is making the molecule of water stick to the side of the wall, that is adhesive. Okay, very difficult to draw here. So right here, adhesive. All right, so you interchange these two. All right, clear? Okay, so I hope that you do make the changes if your textbook has not been corrected. Okay, so that is cohesive and adhesive forces. That is the second property of water. First was polarity. It makes the water able to dissolve many types of solutes. So it's a universal solvent. Secondly, water is able to move up into tiny columns of, for example, xylem vessel or even in capillary tube without dropping, without falling down. Even though water is heavy, right, in certain sense, the density of it's able to move up against gravity because the water will be pulled up literally by the side of the wall, and water pulls water. Okay. Now, lastly, specific heat capacity. So this is specific heat capacity is the amount of heat that is able to be absorbed by a certain what they call the substance. Okay, in order for it to rise to a certain temperature. So water is said to have a high specific heat capacity. Higher, not lower. So what is this figure? What is the specific heat capacity of water? Okay, it is actually 4.2 kilojoules. Kilojoule refers to heat. It can also refer to energy. Okay, any energy is all calculated in joules per kilogram. Kg negative 1 means per kilogram. And then degree Celsius negative 1 is per degree Celsius. So how do you read this? You read this as 4.2 kilojoule per kilogram per degree Celsius. Okay, what does this mean actually? It means that water, all right, is able to absorb heat. How much? 4.2 kilojoule of heat is needed by the water, right, to raise the temperature of 1 kilo of water to become 1 degree Celsius. For example, I have water at 30 degrees Celsius, right, in a beaker, and I put 1 kilogram of water inside the beaker, let's say, all right, a big beaker lah. 1 kilogram of water I put in a beaker, and now the temperature is 30 degrees Celsius. So if I want this water to rise to 31 degrees Celsius, just now was 30, 30 degrees Celsius. If I want it to rise to 31 degrees Celsius, that means increment of 1 degree Celsius, I need to give this 1 kilo of water 4.2 kilojoule of heat. Then it will rise to 31 degrees Celsius. So it's able to absorb the heat. And 4.2 kilojoule of energy is actually quite a lot. Okay, so now besides looking at this, you also sometimes may see 4,200. But 4,200 joule is also correct. Okay, because you see 4.2 kilojoule. If you change it to joule, it is 4,200. Kilo means 1,000. So 4.2 kilojoule is the same as 4,200 joule per kilogram per degree Celsius. You may also see another one, which is also correct. 4.2 joule per gram per degree Celsius. Because this one we measure in terms of kilo. Now, if we don't measure in terms of kilo, it will be 4.2 joule per gram. This is also correct. Any one of these is correct values, the correct data for specific heat capacity of water. Okay, so just remember, you make it life easy lah. Remember the first one lah. Then you can generate your own lah. This one's all same actually. Okay, 4.2 kilojoules of heat is needed to be absorbed by the water of 1 kilogram, not 1 gram, 1 kilogram, in order for it to rise to 1 degree Celsius. So let's say it's 30 degrees Celsius. We want it to rise to 31. This 1 kilogram of water needs to absorb 4.2 kilojoules of heat or energy. Okay, so this is actually quite a lot. Okay, so what it actually means, put it in plain language lah. Put it in plain language. Water is able to absorb a lot of heat before the temperature rises. So that means water is very difficult to warm up, very difficult to heat up the water, right, in order for the temperature to rise. For example, you see on a very hot day, you will go for a swim. You enter the swimming pool. All right, you notice the water is cool. Even though the surrounding temperature may be 35 degrees Celsius, when you enter the water is still very cool. Why? It means the water is able to absorb the heat from the environment. And the rise in temperature of the water is still very little. And that is good because it is able to lower down the temperature. So animals in the sea or animals in the water, they do not suffer any what they call heat stroke, okay? Or will not be very hot, will not be, the temperature of the animals in the water, they are maintained. They do not suffer the heat. All right. So even though the air temperature is very warm, right? You notice when you go into the swimming pool, okay, you're going for a dip in the pool. When you enter the water, you find it's very cooling. The water is able to absorb the heat from the environment, and the rise in temperature is actually very little. So that means even though a very hot day, animals in the water or in the ocean or in the lake, they are still able to survive. Okay, they will not be too hot until they get heat stroke and so on. Okay, so this enables animal to maintain its body temperature. So water is able to, we call it, water is a good buffer temperature. It's able to absorb a lot of heat without even rising the temperature. Okay, so that means animals in the ocean, animals in the sea, they are still able to survive. They are still able to carry on living, even though the air temperature, is getting hot and so on. In the water, you hardly see any changes. Okay, the temperature of the water, of the ocean or the sea in the water, it's still very low. So animals are able to live, to survive. Okay, even though the global temperature rises and so on, water is not a big problem. It will not rise very much because of the high specific heat capacity of water. Okay, so this helps animals in the sea to be able to maintain its body temperature. The temperature of the water doesn't rise, they are still able to survive. All right, okay, so that is my lesson for today, right? Hardly half an hour. So very simple. I know all my lessons were very long, yeah. Okay, sometimes can't be helped because there are so many things to say. Of course, I also very long-winded lah. Okay, I really want to make sure that you understand, so I explain a lot. But today's one is very short and sweet and nice. Just three, properties of water, which I hope that you've understood with my explanation. All right. So I hope to see you in my next lesson. Okay, probably next week. All right. If I have a chance, it should depends on whether I'm free to do the slide. So if you notice that one week that I'm not able to have a class, probably I'm not able to prepare the slide in time. So just wait for the next lesson. All right, the next week. Okay, so I hope to see you again, and thank you very much for watching. If you can, please share the slide with your friends who you think that might need any explanation on today's lesson. Okay, I'll see you then. Bye-bye. Thank you. And share my link with them. Yeah. Okay, bye-bye.